Hey guys, we are on week 6. This week we are adding and subtracting radicals. So I'm going to go over a few things that you need to know before we get started. If you've got 2 or more radicals that have the same index, well, that just means that the radical looks the same. When you have a radical sign and you don't see a little number in the little curve part, it's understood that there's a 2 there, that you're taking the square root. It's the square root symbol. Sometimes you'll see a 3 there. That means you're taking the cube root. Anyway, so if it's got just a regular radical sign, and then you've got the same number underneath, okay, that number is called the radicand. Okay, we've talked about that before. So if it's got the same index and the same radicand, then we can call these like radicals. And we can add or subtract like radicals. And what that means is here, like we've got a square root of 3 and a square root of 3 there. We have different numbers out front, and that's the part we actually add. But it's like having a 2x and a 5x, okay? And you would just add the 2 and the 5. Well, here, so I'm going to put that above. We've got like a 2x and a 5x. I know that's not easy to see, but and then this one, we've got a square root of 3 and a square root of 5. So those are not like radicals. That's like having a 2x and a 2y. Okay, and again, this pen is not great, but I want to be able to write while I talk. So you could not add 2x and 2y. These like radicals can be combined, just like terms, and we would add or subtract the numbers out front. Okay, and we'll just leave the radicand the same. So let's look at what these examples actually look like. So here are 2 really simple ones. We've got 5 times the square root of 2 plus 3 times the square root of 2. The square root of 2 is the same on each problem or each radical expression. So all we do is we add the number out front. We're going to add a 5 and we're going to add the 3. So we have 8 times the square root of 2. And that cannot be simplified. Okay, that square root of 2 is, you can't take factors of that and break it down any further. 7 times the square root of 5 minus 2 times the square root of 5. Well, again, we've got that same radicand number of a square root of 5, so we can subtract the coefficients out front. We have a 7 minus 2. So we just subtract 7 minus 2. We've got 5, and we still have the square root of 5 as our radicand number. Okay, and those are very simple ones. Most of the ones we work this week are not going to be quite so simple. Here's another pretty simple one. This one's a multi expression. Well, we've got 3 different terms. So keep in mind, if you don't see a number in front of your radical, if you don't see a number out front, you know there's really a 1 there. So we have 8 minus 1 plus 2, because all of these expressions have a square root of 7. So we're just going to deal with the numbers out front. So we've got 8 minus 1, that's 7, and then plus 2. So that takes us back up to 9. So 9 times the square root of 7 would be our final answer there. Okay, our next one. Now we've got a square root of 3 and a square root of 2. We do not have like radicands. So anytime you don't have like radicands, you cannot combine them. So if you had to write your answer, it's just going to be the exact same thing. We've got 6 times the square root of 3 plus 6 times the square root of 2. You cannot simplify that anymore. Okay? All right, we're going to stop this video and move on to some harder problems in the next video.